Students, let's start our new session regarding the properties of colloids only. Today we are going to discuss about the properties of the colloids only. We are going to discuss about especially about the physical properties of colloids only. First of all, is there just remember what you could just remember heterogeneous nature only. I already discussed here the colloids are heterogeneous mixture of two or more substances. Colloids are heterogeneous mixture of two or more substances. It is containing of disposed phase and dispersion medium only. Dispersion medium is solvent, dispersed phase is solute only. Okay, based on different number of solid particles, we discuss about colligative properties only. Next one is stable nature. Generally, colloidals are stable only, quite stable only. Their particles are in the state of motion, continuous motion. Generally, remember one point I want to say very clearly. Whenever any colloid is stable means they have a similar charge particle. The similar charge particles always repose together, they will move together. Remember, I want to say very clearly, if you just brought two magnets, same poles near to whatever the repulse happen, no? Similar here also colloidal particles may they containing of the positive charge, negative charge. When they come close to each other, they repulse each other, they will be go away. Next is filtration. Generally, colloidal particles are passed through the general filter paper. Ordinary filter paper is there, no? However, can be written on the specific filter paper. Ultra filter paper you use, no? If you use ultra filter paper, what means you can filtrate the colloidal particles only. Particle size. The particle size of the colloid generally in the varies from the 1 nanometer to 1 meter. Okay, just gonna remember 100 nanometers also. 1 nanometer to 100 nanometers only. Clear. So next one is the color of the particles. Very important. Means students remember here when you see the sky is blue color. Why is sky blue color? Means because of light scattered. Light is scattered because water vapor is in atmosphere. It is scattered by light. That's why you feel the blue color only. Okay, next one is water is blue color only, you know. Water is blue color. Why water is blue color means same phenomena also here also. Whenever light fall on the water, it undergoes scattered. The scattering of light gives blue color to the solution only. I want to say very clear one point is then the color of the any colloidal solution depend upon the two factors. One is the angle of the light scattered and size of the particles only. The color of the hydrophobic salts depend upon the wavelength of light scattered by the dispersed particles, and wavelength of the scattered light again depend upon the size of the and nature of the particles only. It's depend upon size only and depend upon the nature of the angle of deviation also it comes. Remember, you just imagine here. So whenever light fall on the material surface, there under reflection only. So this gives idea. This gives the color of the different materials only. Based on their here wavelength and the size of particles, different color it comes. I'll give an example. Suppose you just take the milk and you just observe the when you pass light. When you just consider when light comes directly, you can see that one is a red color. But if you see the some of 90 degrees angle is there, no, then we'll see the blue color only. So same solution gives different colors are there. Same solution gives different colors. We'll discuss later. Properties of colloidal solution has been classified in three types. One is the kinetic properties of colloidal solution. Remember, kinetic means momentum of the particles only. Next one is the optical properties of colloidal property. Optical, by passing of light scattering. Okay, no? Some electron microscope observation, something else. Next one is the electrical property. I said very clearly, colloidal particles always contain either the negative charge or positive charge. Sometimes both charges also will be there and the unequal ratio only. So let's very important. Let's start our discussion regarding kinetic properties only, which is related to the motion of the particle in the dispersion medium only. You know very well. Also one point is there. When you go for cinema theater, when the switch on the light, just notice here that whenever the screen light is coming, you see that dust particles they will move continuously. It means dust particles are scattered. Dust particles contain some kinetic energy. That's why it's moving. You can also see that in the morning session, in the winter season, you see some water droplets are there because they have some kinetic nature only. So we're discussing about the Brownian momentum. You know very well Brownian momentum of the particles. Diffusion also depend upon the kinetic only. Sedimentation and osmotic pressure. Already we discussed about osmotic pressure and viscosity. Clear. So we are going to discuss about once again I'm saying Brownian motion, diffusion, sedimentation, osmotic pressure, viscosity. Clear. Brownian movement means zigzag motion of the particles because of the unequal bombardment only. Next, diffusion. Diffusion means, very well, the particles are moved from high concentration to low concentration. It's also depend upon the kinetic energy. That's why applying pressure. Sedimentation. Sedimentation means, look at the whenever the particles are there, less kinetic energy, they are going to settle at the bottom. You can see very clearly in the winter time is the most that's particularly settle at the bottom only. Osmotic pressure and viscosity we discussed already. Here next one is optical properties only. In this optical property we are going to discuss about the light scattering effect, Tyndall effect only. Next, ultra microscope observation, how Tyndall effect has happened. Next, electronic microscope only. Next one is electrical properties, very very important. When you're discussing about double layer, zeta potential, okay, electrophoresis, everything, electroosmosis also we'll discuss here. The salt particles carries the electrical charge. Okay, solid in the liquid, generally they carry charge only. Clear? So next one is the electrophoresis. What charge present in the colloidal particles? Why they are getting the charge on the colloidal particles? We are going to discuss in this session only. Next one is electrophoresis. What is electrophoresis means? No, I already discussed here. Colloidal particles having charge only. No, these charge particles are moves towards the positive electrode, negative electrode by applying of the electricity. That's called electrophoresis. Electroosmosis means here the solid particles are moved. Here solvent particles are moved. That's different only. Next one is the streaming potential is there. Next one is the membrane effect only. Donan membrane effect only. These two are not there in our syllabus. These three only we will discuss right now. Let's start. First point is then Brownian movement of colloidal particles. Students, one point I remember one thing is Brownian movement, nothing but zigzag motion of the particles is there. These kind of motions are also possible in the colloidal solution. This is first observed by the scientist name is Robert Brown. What Robert Brown said here, the solvent, dispersion medium containing of charged particles. But in the dispersed medium particles, what happens? Just imagine here the particle is here. In the solvent particle, dispersed medium particles, they are moving unequal charges, they are colliding. But when they starts colliding, the colloidal particles move from here to here. Again move from here to here, like that particles are continuous motion. That is observed by the Robert Brown. That's called as a zigzag motion of the particles, called Brownian momentum only. This is called Brownian momentum. The continuous rapid zigzag momentum of the colloidal particles in the dispersion medium is known as Brownian momentum only. The Brownian momentum of the particles are depend upon the two things are there. Whenever high concentration is there, the Brownian momentum is very less. Whenever low concentration is there, the Brownian momentum will be takes place easily only. Clear? That's one point. Brownian momentum is depend upon the independent on the nature of the colloidal particles, but depend upon the size of the particles and viscosity. Size of the particles and viscosity decides the Brownian momentum of the solutions only. Next, sedimentation process. You know very well sedimentation process already discussed here. The colloidal particles having charge is there, no? So at small particle size is there, no? Just less than 0.5 micrometers are there. Brownian motion of the significant and tend to prevent sedimentation due to the gravity and promotion of mixing only. It means here the particles are always continuously moving only. Look at here, whenever the size of the colloidal particles are increases, they try to sediment, they form a precipitate. When they form a precipitate, the colloidal properties will be disturbed. That is called as a flocculation and coagulation. The colloidal particles settle down under the influence of the gravity at the very slow rate. This phenomena is to determine the molecular mass of the macromolecule. Molecular mass also can be decided the how much time is taken to sediment of the colloidal particles only. Next one is kinetic property diffusion only. The salt particles are diffused from high concentration to low concentration region only. Salt particles will be diffused. Look at the students, I am taking the water. When I add small amount of ink drop is there, no? When I add small amount of ink drop, after few seconds the ink is starts spreading in the solution. After few minutes the excess amount is spread. After 1 hour, 1 hour, 1 day, you can see the total solution become the blue color. Why this happen means one point remember, in the water always particles are continuously motion. Because of continuous motion of the particle, this color is spreading easily. This phenomenon because of the kinetic energy of the colloidal particles only. Kinetic energy of the colloidal particles only. Next one is viscosity. The viscosity of colloids depend upon the shape of the colloidal particles. Sphere of the colloidal particle shows the low, whereas in the linear shows. General viscosity is depend upon the size of the colloidal particles only. Colloidal particles are macromolecules, they have high size only. Next one is osmotic pressure. Osmotic pressure depend upon the number of particles on the dispersion phase. Okay, now osmotic pressure means you know very well. Already we discussed osmotic pressure. Two chambers are there. When two chambers are there connected to each other. Look at students. Just notice here that I just made a small diagram is there. No? In this one, two chambers are there. Look at this one, red color nothing but solid particles are there. Here is the yellow color solvent particles only. Look at in this side is there no more amount of solid particles are there. Here less amount of solid particles are there. So what happened? Just imagine initially here I said very clearly during the osmosis process, only solvent molecules move from the low concentration to high concentration. Initial up look at the initial up to here is the water level is there. When time leads what happened, the water level will be decreases. The solvent molecules move from semi-permeable membrane. This called membrane is called as a semi-permeable membrane. It means it allow only solvent particles pass through it. Solid particles are never dispersed. Phase particles they cannot be moved only. So what happens when our solvent particles move, the water level will be increases. This is known as osmotic pressure. This process called as a osmosis process. It depends upon the nature of the particles in the dispersion. Okay, in associative colloidals, each aggregated act as some particles only. Osmotic pressure developed is called osmotic pressure only. Already we discussed in the solution only. Look at this diagram is done here. Pure water they have taken, a semi-permeable membrane they have taken. Here taken there the colloidal solution is there. Look at the water levels are here. Look at the here also water level. Just look at here. When time leads, what happens there? The generally the solvent molecule will move. Whenever solvent molecule will use, the water level is increases here. Look at the water level. You can see very clearly water level increases. This happens because of the osmosis process. These are example of the Brownian momentum only. The zigzag motion of the particles happen. Okay, diffusion nothing but look at diffusion nothing but here particles is moving from the high concentration to low concentration only. Nothing but is coagulation, sedimentation of the particles only. Let's start students very important. The optical property nothing but a light scattering experiment only. I want very clearly how can you, if they ask questions, you know, how can you distinguish between the true solution and colloidal solution? Already we discussed about that. If you take the one light, if you pass the light to the true solution in the dark room, if you place here, you can see the okay light is you cannot see the light is coming from the passing through the solution only. If you take any colloidal solution, you can see the very clear path is the path we clearly indicates is that the light is moving from here to here only. Because what they are doing now here, why? Because of here the particle size is very small, so they cannot scatter. Here particle size is very large, they can be scattered and they can use some color only. They can use some color only. Look at the when a strong beam light pass through a solution, you can view it at the right angle. The path of light shows up on the hazy. Look at the here. Look at it. Just imagine here. If your light is passed on true solution, you can transparent only. If when you pass the colloidal solution, it's translucent. When you pass the colloidal solution, it's translucent. Okay, we can look at here. Just imagine here. When you are just standing here, just notice here I can just simply the light is coming light. You cannot see any scattering also. But you can see here that when you see here, the light will be scattered only. But if this is called 90 degrees right angle triangle, by using some microscope only, you can see the microscope. You can see here. Look at here. Just imagine here microscope is there. Through microscope, you just notice here that when a light is coming here, we cannot see the solid particles. Why we cannot see solid particles? Means here in the true solution, the solid particles are very small size only. Okay, here when you sit here, when you just notice here that you can see very clearly the colloidal particles, because when our light fall on the colloidal particle, they will scatter. This depend upon size of the colloidal particles. Because of scattering of light is then you can see very clearly the colloidal particles what are the present in the solutions only. Okay, now you just consider this scattering of light is called as a illumination, and path of the beam is in the dispersion. Look at here, this is called illumination only. You can see very clearly the path is coming, the light is coming from the solutions only. The illuminated beam of the core of from the formed by the scattering of light by the salts particles are then after referred as a Tyndall beam. That is called Tyndall cone only. Tyndall cone. Just one point remember, true solution do not show the Tyndall effect only. True solution do not show Tyndall effect is there because of the solid particles are very small. Okay, students, look at it. Look at this torch light is there. When I pass light, what happens? Just consider through true solution, we cannot see the any scattering of light is. When if you come to colloidal solution, you can see very clearly the path of light is traveling. The path of light is traveling only. Look at this is the source, nothing but this cone is called as this is called Tyndall cone. Because Tyndall cone, because Tyndall cone, what happens? The light will be focused on the colloidal particles. Because of large size of the colloidal particle, light will be scattered. Whenever light will be scattered, they will be illuminated. Some look like this, they will be illuminated. They give some color. Because of that color only, we can see the colloidal particles. So this is called as a Tyndall effect. This is called as a Tyndall effect. So you can see the ultra microscope only. Look at here the particles you can see through ultra microscope only. Look at here. Just remember here the solid particles cannot be seen with the microscope only. Generally, we cannot see with our naked eye also. We cannot see simple microscope also. Just scientist name is the Jigmodi. Okay, Z Sigmodi they will call as a. Here use the Tyndall phenomena to set up the operators. Do you know very well now students as a biology student they will see the like a plant specimen, some microorganism through microscope only, how they are seeing means based on this phenomenon only. Based on this phenomenon only, when our light will come on this slide will be there, no? You look at the slide is there, no? When our light will focus on one single point, the other single point on the slide, not a scattering only. Because of the scattering only, you can see very clearly this is the what are the particle slide placed here. No? Clear, no? The focus light is then observed with a microscope at right angle to the beam only. Right angle to the beam means this one only. Okay, individual solid particles appear as bright. Okay, speaks general specks of light against dark background is there. Look at it, just consider that's the reason initially we just you apply you remove this focal, just rotating this focal length, you can see the particles only. Look at here, just consider that when our light comes here, the light will scatter on the particles. They will scatter, they give some color. That because of the reason only you can see the particles very clearly. An ultra microscope does not give any information regarding the shape and size of the solid particles only. This is very important. It's not giving an idea, it's saying the particles only. Look at here, the colloidal particles is like that only. Let's next very important point is I said very clearly, colloidal particles having charge. Colloidal particles having charge, either positive charge, negative charge only. Okay, now this one electrical properties of the colloidal particles. I already discussed about dialysis also. Dialysis, when you do dialysis, you go for when you apply the electricity, the dialysis process happens very fastly. The most important properties of the colloidal dispersion is that all the suspended particles possess either a positive charge or negative charge. Here colloidal particles may be positive charge or negative charge only. This is the medium, dispersion phase only. Either dispersion medium also containing charge or dispersion phase also containing charge. No, anything is possible. The natural forces of repulsion between the similar charged particles prevent them the aggregation only. I said very clearly here both similar charge only, no? Both similar charge, what happens, both when the clump close to each other, they will start repulsions, again they will start moving. That's the reason why particles of in the colloidal solution is continuous motion only. Okay, no? Generally they will never settle at the bottom. If charges are not there, no, suppose if you look at the negative charge, positive charge combined, they become neutralized. No? The particles under the sedimentation process is called a flocculation or sedimentation only. Okay. Students, the most important thing is there. No? One point you just remember here, so you'll get one doubt is there. Sir, whether colloidal particles can you set positive charge possible, negative charge possible, how they will get this charge? So for that one is then I have two methods is the preferential absorption method and next one is the dispersion method only. Preferential absorption method, look at that preferential absorption method. Next one is the electron dispersion method only. Look at students, I'm just taking one beaker. In this beaker colloidal solution is there. This colloidal solution doesn't have any charge. Clear? When I add the metal into the solution, colloidal solution, this metal in the aqueous solution becomes the metal positive one electron. When our colloidal particles gain this electron, they will get negative charge. They react as negative colloidal particles. Suppose this colloidal particles gains positive charge, they will become positive charge colloidal particles. This is called as a metallic dispersion method. Generally, this is happen depend nature of the colloidal solution only. I said never say all colloidal solutions are positive charge, all colloidal solution negative charge. Here and whatever the charges get in colloidal solution depend upon the preferential absorption only. Preferential absorption, which one they have taken. Clear which one they have taken only. Next one is most important thing is electrical double layers only. Electrical double layer. What is electrical double layer means? You know very well when you take any colloidal solution. If you take any colloidal solution, this is colloid is there. No, this colloid may get either positive charge. Okay, no? Either positive charge get negative charge also possible. Colloidal solution also negative charge possible. Okay, what happened there here? The what just consider that the surface of colloidal particles acquire positive charge by selective absorption. Suppose here the one positive charge is absorbed in the colloidal solution, that is positive charge you get is there. A layer of positive charge is around the it. a layer of positive charge is formed. So look at the layer of positive charge developed around the colloidal solutions only. So here this layer attracts the counter ions from the medium from second layer only. Suppose this positive charge colloidal particles attract the negative charge colloidal particle only. Suppose it attracts the negative charge particles, negative only. So what happens here? The one layer, look at here, this one layer is there, and second layer is forms around this colloidal particles only. This is called double layer only. So this double layer, what happens? They just consider the second layer of negative charged. The combination of the two layers, the positive negative charge layers, is called as a double layer only. This combination of these two charge particles are called as a double layer only. More general double layer is this called stationary phase, stationary layer only. This is stationary layer, non-mobile layer only. Static layer also is called a static layer only. This is called mobile layer only. This is called as a mobile layer only. Okay, a compact layer has a positive or negative charge will yeah, which a fixed familiar part of the, look at the compact layer of the positive and negative charge which are fixed firmly on the particle side. Look at the positive negative charge, they will be fixed on the around the colloidal particles only. Diffuse layer, I said very clear, diffuse layer of the counter generally negative charge particles only. These negative charge particles are diffuse layer, they can easily move only. The combination of the compact and diffuse layer referred to as a double layer only. This is these two combinations called double layer only. Because look at here, the just imagine here the look at the, because of the positive charge and negative charge is there, no, some potential develop around this two layer only. That's potential called as a zeta potential. That potential called as a electrokinetic potential or zeta potential only. And it's very important because of two charge difference in two layers is there, no, some potential difference develop. It's called as a zeta potential, double layer potential only. Okay, electrokinetic potential. Just look at, you will get very clear idea is then this colloidal particle absorbs the positive charge, positive charge become around the positive charge, negative charge particles are attracted. So is there, no, this is called as fixed layer. This is called as fixed layer which is surrounding the colloidal particles. The next layer is called mobile layer. This is called mobile layer only. Just imagine here the colloidal particles, here the fixed layer mobile layer is there. Around this one again fixed layer mobile layer is generated, no, that is called as this is called compact layer. This is called diffuse layer. Because of look at the different charges are there, some potential developed. It's called as zeta potential. That is called as a zeta potential only. Let's have the next one part is electrical properties of colloidal solutions only. So when we discuss about electrical properties of colloidal solutions only, we discuss about electrophoresis. What is electrophoresis? Means by applying of electricity we want to convert colloidal particle into suspension only. When you pass the electricity, what happens there? The colloidal particles move towards the opposite electrode. They will settle at the bottom. They will settle at the bottom. Look at it. Suppose I'm just taking here one. Look at the here one chamber is this called anode only. This one anodic plate is there. This is cathode. This cathodic plate is there. Here colloidal solution is there. In this colloidal solution, I'm taking dispersal phase particles. Solid particles are negative charge particles only. Solid particles are negative charge particles only. Initial level of the water. Look at the initial level only. Okay, water in general they are taken water as a solvent only. A reservoir is there. Look what happens there when you pass when I apply the charge, when I apply the electrode potential, what happens there? Negative charge particles are slowly moving from the here negative electrode to positive electrode. Suppose if I take the here colloidal particles having the positive charge, when I apply the electrode potential, the particles are moved towards the opposite electrode. When they move towards the electrode, what happens there? They lose their charge. They will settle. They will undergo chargeless particles only. That's nothing but a electrophoresis. This is called electrophoresis. Look at the colloidal particles are all either carrying the positive charge and negative charge only. The existence of charge of the colloidal particles can be demonstrated by a phenomena is called electrophoresis only. Look at here, what are the charged colloidal particles are, the charge can be removed by the different methods are there. For suppose if you add some electrolyte also, if you add some electrolyte, suppose if just colloidal particles have negative charge is there, na? When I add positive charge electrolyte, negative charge, positive charge, they will be combined, they form neutral only. Either way, if I heat the colloidal particles, the colloidal particles bombard very fastly and they lose their charge, they will undergo sedimentation process, sedimentation or flocculation process only. So next one is then generally by add, look at suppose here the colloidal particles they are having some electrolyte is there. If I remove the electrolyte by using the continuous dialysis, what happens there? No electrolyte is there, the colloidal solution becomes to precipitate only. Okay, colloidal solution becomes to precipitate only. Next one is electroosmosis. Generally solid particles are then in the electrophoresis, solid particles are moved. In the electroosmosis, solvent particles amount. Sol is electrical neutral. Therefore, the dispersion medium carries an equal but opposite charge only. So that of the dispersion medium only. Look at here. Remember here. Just consider the very important students. Some students will get doubt here. Look at dispersion medium only. In electrophoresis, dispersion phase particles move. In electroosmosis, dispersion phase particles are neutral. Dispersion medium particles will be move only. Clear? Dispersion medium carries the unequal opposite charge. Of that the dispersion phase particles, they will move only. This is called electroosmosis. Look at students, this is electroosmosis operators only. In this electroosmosis operators, here look at here colloidal solution is there. A colloidal solution dispersed phase particle doesn't have any charge is there. Look at the dispersion medium, like solvent particles having any solvent particles either having any charge. It's a positive negative charge only. In this one is look at semi-permeable membrane only. It allow only solvent particles move from here to here or here to here only. Here two electrodes are places. One is positive electrode is anode, one is negative electrode cathode only. Suppose look at here the volume of look at here also water is there. No, here just measure the exact value. Some reading will be there. Here also reading will be there. When you apply the electricity, because the unequal and look at the solvent particles having the positive charge, the solvent particles move from this chamber to this chamber. Whenever the particles are moving, what happens? The level of this reading will increase one. Suppose look at the colloidal particles having the charges. So what happens here? Just suppose here the colloidal solvent particles having the negative charge. So in negative charge, when apply electricity, the particles move from here to here. This is called as a electroosmosis. This is called electroosmosis. Look at where they mention very clearly. This is semi-permeable membrane. You look at the colloidal particles are moving from the one position to another. This is called electroosmosis method. This is called electroosmosis. Coagulation precipitation. Generally, I want to convert colloidal solution to precipitation. Is there no? This method again I go for this method only. A flocculation or settle down of the colloidal particles is known as the sedimentation of the colloidal particles is called flocculation or sedimentation only. Generally, they are did by the following method by addition of electrolyte. Suppose look at a colloidal solution, each electrode is there. No? When I add a positive electrode under sedimentation only by electrophoresis, by applying electricity, they will lose their charge. By mixing of two opposite charges also only by boiling process. All this process and apply will convert. Look at the by adding of electrolyte. When X of electrolyte is added to the sauce, dispersed particles are precipitated. The electrolyte finished both positive and negative charge ions in the medium only. Look at that. Generally, when you add the electrolyte, what happens there? Suppose here the colloidal particle having negative charge, if electrolyte containing positive charge, they undergo coagulation is settled at the bottom only. Okay, this is given by a scientist name is the Hartley-Schulze rule only. Okay, this is called Hartley-Schulze rule only. State that precipitating effect. Generally, suppose I'm just imagining here whenever the charge on the cation is increases, easily precipitate the colloidal particles only. Okay, no, easily precipitate colloidal particles only.